Yeah, hello student. Today we are going to see the next practical of that is writing a program for interfacing with the 805 PIC controller. Now here we are going to see the interfacing with the PIC controller in a square wave. Okay, so the practical is we have to see the output using timers, and other we have to see the timer using timers and interrupt. Okay, so what are the requirement for this practical? The first, we need a PIC kit. Second, we need an USB cable. Third, we need a 9 volt power 9 volt supply. Okay, and we need the FRC cables. Okay, these flat FRC cables. These are the requirement before starting the practical. Now let's start with the practical. Now we know that for PIC microcontroller we are using the ID MP lab ID. So we'll just open the MP lab ID. Yeah, so we'll just open the MP lab ID. Now as you know the procedure, what is the first pass is that we have to create a project wizard. Okay, so we'll create a new project, say next. Then which IC? Now the important is the number of this IC, PIC 184520, and the IC which is on a kit should be same. Then next we have to select in the active toolkit, we have to select microchip 18. Okay, and that we have C18 compiler. Okay, and these are mandatory, otherwise our program is not going to run on the hardware. Then we have to see where we are going to see, so I'll just write it is we have to generate a delay with timer. Okay, so this program is generating of a delay with timer. Okay, only using timer, that is we are just going to see the glow of an LED on and off using timer. Okay, the delay which will be generated with the help of a timer. Okay, so we'll just say next and finish. So we have created this. Then we just have to go and say a new file. We have created a project, so I'll just take the program from here. Okay, Control 8. Okay, now this is a program. Now what is important, we need to save this program. Whenever we are going to save this program, we have to see that we are saving it in a C file only, because if you don't save in the C file and so save as type, that is we have to write C source file. Okay, so once we have done, you'll just say save, and you can see the color has changed. Verify, you can see the color have changed. Now what this program is, now we know that we need a header file, so we have used the header file hash include pic. Then we have used the hash pragma, that is the pre-directive to the compiler. Next is we are going to start with the void main. In the void main we have said tristate is equal to tristate B is equal, because we are using the port B. So at that time we have to make output, that is we have to give an from the controller we are giving the output to the tri-state means it decide whether we are using that port as an output port and input port. So we are giving the output to the square wave, that is we are generating a square wave, but indirectly instead of using a square wave we can just use the LEDs. Okay, then we are using a while one, means this is going to be always in while one. Now I have used a simple program for LED glow. LED glow means hash port LED, we have used the port P. Okay, then we are calling the timer delay. Now why a timer delay? Now we are not going to call a generalized delay, we are calling the precise delay. Now why precise delay? Because it is going to create a delay of 10 milliseconds. Okay, so from here the control is going to go to the timer delay. Then we are using the timer control register with 08. Now these are the configuration register, you have to see the configuration written Y08. TMR 0H and TMR 0L. These are the two values which we will be getting with the calculations, which will be telling us that exactly 10 milliseconds delay has been created. Then timer control bit timer on. So we are just going to start the timer. We are going to continuously monitor the flag register, because until unless it moves from that from 9E58 to FFF, it is going to be 0. Once it goes to once the timer flag increases, the TF is going to be 1. So here you can see there is a semicolon. It means until 0 it will be here. Once it acquired that value, that is when when it goes to FFF, it will come out of this loop, and we are going to turn off the timer. We are going to clear the timer flag. Okay, so this is a program. So once we have done this, we just have to build it. So we will just hold on. Now before this, we need to add. Okay, so this is our code. So in the source file, we need to add this. So what is the name? This timer delay. Just say open, and now we will build this code. Okay, so you can see very carefully that the code is built successfully, and the other important thing is that is we have created an hex file. Okay, so once this is done, the work of the ID MP lab is over. Then we can go to the tiny bootloader. So we'll just go to the tiny bootloader. Okay, next is tiny bootloader. Now this is not an application, this is a file. We just have to go and just open this application, tiny bootloader. It's an application. Directly we have to open this application. Now once we open this application, what is important here that we have to go to the device manager. We have to go to the device manager. Okay, so you have seen the device manager, and you have to check whether the kit is connected. So once we have confirmed the Silicon Lab kit is connected and it is connected to COM3, then we can, in the tiny bootloader, we have to select this COM3 and COM3. Then what is the baud rate? Here the baud rate is going to be 115200. Then we have to check the device. We have to turn on the device to everything, and then we have to check the device. We'll just check the device. Yes, once the device is checked, you can see that a number is detected. That is the device number 18F252452255204520. This is the number detected. Once this number is detected, just go to the browser and you browse the file which you have created. So through MP Lab ID, we have this hex file. Okay, so we are going to create this hex file. So we'll just browse, and we have got this hex file. Okay, and no, this is not a hex file. This is a delay timer.hex file. So we are just going to take this timer hex file and we are going to write it on a kit. Okay, so you can see it is successfully written. Once it is successfully written, the work of now the tiny multi bootloader is over, and now we will concentrate on our hardware. Okay, so we will go to the program and see which port we have used. Now if you go very careful, if you do this, we just need just open the program, which port we have used for the LEDs. It is written here itself only, that is port B. Okay, so we are just doing on and off of the LED, but by using a precise delay. So we will just connect to port B. Just hold on, we'll connect to port B. The FRC flat cable we are going to use for this, and you just connect to the LEDs and you just say reset. Okay, once you say return, you can see the on and off of the LED. Now this on and off is taking 10 milliseconds to turn on and turn off. Okay, so this is one of our practical. So you have to carefully watch that all this is blinked. Okay,